cloud. All right, so we are looking at this nice handy list here. So up at the tippy top, it's asking us, or I guess showing us, hey, if I wanted to prove that I had some random quadrilateral and I wanted to show that it's a parallelogram, what are the ways in which I could do that? So there they are for you. You can either show me that you have two pairs of opposite sides parallel, two pairs of opposite sides that are congruent, one pair of opposite sides parallel and congruent, the diagonals bisect each other, or two pairs of opposite angles congruent. So those are your 5 ways to prove that a parallelogram is in fact a parallelogram. So we have talked about that already. So now let's look at, well, what if I wanted to go further? If I wanted to show that something is a rectangle or a rhombus or a square or what have you. So let's see here. If I want to show that I have a rectangle, I can do one of these 3 things. You don't have to do all 3. These are just your 3 options. So you can show me that it's a quadrilateral that has 4 right angles. So if you can show that all 4 angles are right angles, it's got to be a rectangle. Alternatively, you can show that it is a parallelogram, which means you have to show that one of the 5 things at the top is true. So you'd have to get one of these top 5 things first, and then also show me that you have congruent diagonals. Or show me it's a parallelogram and then just show that one angle is a right angle. Then they all would be. Okay, but you got to be careful with these because you'd have to show that it's a parallelogram first. And then, or well, I guess it doesn't have to be in that order, but before you're done, it would have to be a parallelogram and show congruent diagonals, or a parallelogram and a right angle. All right, so those can be a little bit tricky sometimes. So same thing is happening down here with the rhombus. You can show me that you have a parallelogram and then just 2 sides in a row are congruent. A parallelogram with either diagonal bisecting opposite angles or both diagonals perpendicular bisectors of each other. So make sure it's both, because remember the kite has one that's a perpendicular bisector but not the other. So you'd have to show both. Okay, you want to show something as a square, you got to show that it's both a rectangle and a rhombus. You want to show that it's a kite. 2 pairs of consecutive disjoint sides congruent. So that just means, when we are saying disjoint, that just means that you have 2 separate pairs. So there's a pair that's the same, and then down here is a pair that's the same. You can't have all 4 be the same because then it would be a rhombus. So disjoint just means you have a group here and you have a group here and there's no overlap. So you have these 2 separate pairs of congruent sides. Okay? Or you could show that one diagonal is a perpendicular bisector of the other. And lastly, our friend Isosceles Trapezoid. How do we get there? Show me that you have a trapezoid that has congruent legs. That fits the definition. You could also show that it's a trapezoid with congruent base angle pairs or a trapezoid with congruent diagonals. So any one of those would get you an isosceles trapezoid. All right, cool. So now let's put all this into practice. So if you flip this over, oh, how handy. I have a couple of proofs for us to try together. Let's see how we do. All right, let's look at this thing. So I'm given a bunch of information. My goal is to prove that this thing is a rhombus, right? So I have the luxury of having 2 copies here. So if I want to prove something is a rhombus, I can show that it's a parallelogram with any 2 consecutive sides congruent. I could show that I have a parallelogram and either of the diagonals are bisecting opposite angles. I could have that. Or I could show that both diagonals are perpendicular bisectors of the other. So those are my 3 options. Let's see where I can even go with this. All right, let's write down the given, mark some things up, see where we can go from here. Zoom out a smidge. All right, so in the given, I know that BF bisects CBA. DE is going to be parallel to BA. All right, cool. And GE parallel to BC. All right, all that's in the given. Let me go ahead and mark what they're telling me. DE and BA. And GE and BC. Woo! So what do I have already? What kind of a shape does this thing have to be already? It's got to be a parallelogram. They gave me that both pairs of opposite sides were parallel. Oh, how nice. So what I might do is I might say right now, GEDB is a parallelogram. I know it's a parallelogram because it satisfies the definition. I have both pairs of opposite sides parallel. So I can literally just write definition parallelogram. Nice. Okay, don't forget there was another piece of the given. It said that BF bisects angle CBA. So CBA is this angle right here. BF is going to bisect it. I'm going to be lazy and put in angles 1 and 2. What can I say about angles 1 and 2 now? They have to be equal. So angle 1's got to be congruent to angle 2 because of, you got it, definition bisect. They use the word bisect, that's what bisect means. I'm going to go ahead and mark them congruent in my diagram. All right, so now I need to take a pause and sort of figure out where I'm at. That's all the stuff that I kind of got really easily just from what they gave me. Now I got to sort of plan this out because I got to try and make this thing be a rhombus. So if I look at my list for things that I could show to make a rhombus, parallelogram with 2 consecutive sides congruent. I could probably do that, but it doesn't seem like it's that easy because I don't have any sides marked congruent right now. So maybe I could get there, but I don't think that's probably going to be my best option. Let me see what my other choices are. Oh, a parallelogram with either diagonal bisecting opposite angles. Well, I'm almost there, aren't I? I have this diagonal is bisecting this angle. All I'd have to show is that it's doing the same thing over here. Right? With either diagonal bisecting opposite angles. Yeah, so if I just show that these 2 angles, 3 and 4, let's say, if I can get those to be equal, I'd have that. Let me just check the third and see if that's even easier. Both diagonals are perpendicular bisectors of each other. I don't think that's going to be easier because I don't even have I could draw in the other diagonal if I wanted, but I don't think that's going to help me. Maybe I could go down that road, but I think I'm really close to sort of the middle option. Do you guys agree? All I need is to get these 2 to show that 3 and 4 are equal to each other. Because then I have this diagonal that's bisecting the angles of the rhombus. I already showed that it was a parallelogram, so that part I can already check that off. All right, so any thoughts how I can get there? Can I? Sam?
You say B equal B is equal to angle B because of like did you use CB to C?
No, but you're not wrong. They are, but you would say opposite angles of a parallelogram are congruent. I know this thing is a parallelogram, so I can say all those fun facts about parallelograms, you can say them. So I don't think you're not wrong. I don't know if that's going to help us. I don't think it's going to help me, but you're not wrong. Go ahead.
Because AD is parallel with G.
Oh.
Interior.
Alternate interiors. That's where I would go. You have parallel lines, so you have a whole bunch of alternate interiors. So wouldn't it be true? Let me zoom in a little bit so we can see just a little bit bigger. wouldn't it be true? These lines are parallel, right? They're getting cut by a transversal. So wouldn't 2 and 3 be the same? Right? Oh, but then oh yeah, I can say the same thing for 1 and 4 because they are alternate interiors too. So, oh my gosh, let's just say that, and then doesn't that show 3 and 4 are the same? Yes, even.
You have to say that like BE is equal to BE.
No.
Okay.
Not unless I was trying to get these two triangles congruent, and I'm not, so I wouldn't need that here. So let's go ahead and say what we just said. So angle 2 is the same as angle 3. And for the same reason, I might as well just lump it in. Angle 1 is the same as angle 4. Oh, I'm sorry. And remember, that's because parallel lines are giving me congruent alternate interior angles. I'm trying to get 3 equal to 4 though. Do I have enough to say that? Can you say that 3 is equal to 4 now?
Yeah.
Yeah, why?
Substitution, because if 1 is equal to 2, then 2 is equal to 3, 1 is equal to 4. Then
Yeah, here's a good example of transitive when you're doing multiple substitution. If you say substitution, I would take it. But remember, you want to follow the chain. So if I'm saying 3 is equal to 4, take your pencil and make sure that you can jump. Okay, 3 is the same as 2. 2 is the same as 1. Yep, 1's the same as 4. I made all the links because I can't tell you how many times kids think they have the link, but they didn't put it in there. And then if you actually follow the chain, it's broken. Ours is not though. We went all the way from 3 to 4. We got it. So I'm going to say transitive for that. So now I have shown, I guess I probably wouldn't take any points off if you just left it like this, but it wouldn't be a bad idea to just say, so now I've shown that BE has bisected this angle also, right? Because remember in the given they said BF bisects CBA. So now let's just say the same thing, but about BE bisecting DEG. I don't think that's a bad thing to throw in there. Again, if you left it off, it's probably not that big of a deal, but better to have it right than not. So BE bisects angle DEG. What would my reason be for that? What would you say? Bless you. How do I know that to be true? Go ahead. What do you think?
Like, I don't know. Equal angles, I don't know.
I'm satisfied that what does bisect mean? It means it divides it into 2 equal angles. I've shown that I have 2 equal angles, so I have satisfied the definition of an angle bisecting. So I can still just say definition bisect. I showed that I fulfilled that. So now I have done everything that I needed to show that this thing is a rhombus because I showed it was a parallelogram and I showed that it has a diagonal bisecting both angles. So that's all I need. So 7, I know for sure that GEDB is a rhombus. And then my reason, I would just put whatever it says here. Parallelogram with diagonal bisecting angles. Would you like a tidbit of good news as we go into our last proof quiz? I'm gonna give you a copy of this. So don't feel like you have to like memorize all these things. Okay, so you will have that to refer to when you take that last one. So how do we feel about that one? That wasn't so bad, right? So I'd like to just ask myself, okay, which route am I gonna go down? what is easiest for me to get. So let's try this trapezoid looking one. Oh, they start me off with a parallelogram. That's always good. And I have two angles that are the same. I'm trying to prove that zoid is an isosceles trapezoid. So let's see how we prove isosceles trapezoids even are isosceles trapezoids. So for all of the three choices, I have to show that it's a trapezoid to begin with. Because remember, they didn't tell me that zoid is a trapezoid. So I'm going to have to do that. All right. But luckily, that's not so bad. How do I show a trapezoid is a trapezoid? What does it have to have, Carson?
One set of parallel lines.
Exactly. I just have to show that I have a pair of parallel lines. So now I know I have a trapezoid. All right. So, any hoosers.
Don't we already have that?
Sort of. I need to say it though. They didn't tell me I have a trapezoid. They didn't tell me I have parallel sides, but they told me I have a parallelogram. So that we can use. All right. Where am I gonna? I will put this. I'm gonna try and fit it in right here. I still want room for the other one. Okay, let's see. They gave me parallelogram ZOIM and angle D equal to angle I. All right, cool. So first step, let's get this thing to be a trapezoid. How will I show that the top and the bottom are parallel to each other? Carson, go ahead.
Well, if ZOME or ZOIM.
Yep.
Is a parallelogram, then that means the top and bottom is not a parallel, the right and the left are parallel.
Exactly.
It's just the top and bottom are parallel. That gives you a top.
Exactly. You don't have to worry about, because I always get this question, if ZO is parallel to MI, like, do I have to do anything special to show that this whole line is parallel? No, you don't. Any piece of a line, because lines go on forever, right? So you don't have to worry just because it's MI parallel to ZO. It doesn't matter. It counts for the whole thing. So let's go ahead and say that ZO is parallel to, I'm even going to say DI. 2, and all I'd say here, opposite sides of a parallelogram are parallel. I guess you could even get away with saying definition parallelogram, because that is the definition of it, right? Two pairs of opposite sides that are parallel. You know what? I don't know if I'm going to need it, but I'm just going to throw in the other sides too, just in case. So I'm also going to throw right on ZM parallel to OI. Because it's for the same reason. I might need it later. I don't want to write more later on. Like, I don't want to make a new step if I could have just lumped them together here. So might as well, can't hurt. All right, I also know from the given, I didn't mark this yet, D is congruent to I. Okay, cool. So now let's see. We have enough to say that this thing is a trapezoid, so we should probably do that. Yep.
How do you know that zero is dark?
Well, so I know that ZO and MI are parallel, right? Since this is just an extension of that same line, you can just say the whole line.
Okay.
Yeah, you don't have to do anything special. Okay, so let's go ahead and say that we have a parallelogram now. So ZOID is a trapezoid. Did I say parallelogram? I didn't mean to. I'm sorry. Blah, blah. Erase that from your brain. It's a trapezoid. How do I know? I've satisfied the definition of trapezoid. I have a pair of parallel sides, so I know I've got that. All right, cool. So now let's see what I need to show it's an isosceles one. I need to show either the legs are congruent, so that would be showing ZD is equal to OI. So there's an option. If I show that I have congruent base angle pairs, oh my gosh, I do. Oh, that was a lot easier than I thought. Well, how about that? I have congruent base angle pairs. So yeah, this thing is an isosceles trapezoid. Okay. So I'm just gonna say it's a trapezoid with congruent base angle pairs. Well, that was a lot easier than I expected. I thought for sure I was at least gonna have to do, I wonder if they meant to say that I feel like it shouldn't have been that easy. I wonder if they meant the angle ZMD. I don't know, whatever. Either way, we got it. Let's try the last one. We're trying to prove that this thing is a kite now. Let's see how we can do this. Okay. We have one line that's bisecting two angles. I'm supposed to prove that CRAS is a kite. All right. Bless you. RS bisects angle CRA and CHA. All right, that's all I'm given. So first thing, whenever they tell me bisect, I'm going to come in here and say that those two angles are the same, right? Oh, wait, it's not that one. CRA and CHA. So it'd be those two that I know. All right, be careful. So I could say angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. I got that, I got that, I got this and this. Okay, now let's see what I need to prove a kite is a kite. So I could either satisfy the definition by showing I have two pairs of disjoint sides that are congruent. So that would be showing CR the same as RA and showing CS the same as AS. So that's one option. Or I can show that one diagonal is a perpendicular bisector of the other. So yeah, I don't even have the other angle drawn, but that doesn't mean that it's you know, wrong to have it. But oh, I actually feel like I could do that pretty easily. If you drew in that other diagonal, I feel like I could get that pretty quickly. Oh, wait, no, because I'd have to know that it's perpendicular first. Yeah, never mind. I thought I had a quick slick trick there, but I don't. Yeah, so I'm probably not going to go with that one. I'm probably going to try and show that CR is the same as RA and AS the same as CS. Carson?
I noticed that the diagonals in the kite are always perpendicular. Is that true?
That is true. But you have to know that it's a kite first, right? I don't know that this thing is a kite yet. So let's see, what can I do? Anybody have any thoughts? Let's focus on getting these two sides the same. Go ahead.
Well, you can, I don't know how to like say it properly, but you can find like angle RHC and RHA by subtracting angle 3 from 180 or
That's a great idea. So if we could get, well, first of all, don't these two, if I could get these two triangles the same, then I could say these two sides by CP. Yeah?
Yeah.
Okay. So what I could do is I can, if I look at these two, I already have an angle. They do share this side RH between them. So I could say that. So Aiden's right. If I could show that 5 and 6 are the same as each other, I could get these two triangles by angle side angle. And I can get that, right? If I know that 3 and 4 are the same, that means 5 and 6 will be the same too. I just have to say it. Question?
That's what I was gonna say.
Oh, all right.
Because, if 4 and 6 make a line, so that it both have 180, then 3 and 5 make a line, it will have 180. And if 3 and 4 are equal, 5 and 6 make a line.
Does everybody remember the name of that thing that basically said all that? Linear pair is what tells me that 6 and 4 together make 180. But there's something that says,
There's two theorems for supplementary definition and then
it's, let me tell you, the congruent supplements theorem. That says if two angles are supplementary to the same or congruent angles, they're equal to each other. That's what we have going on here. So, but we kind of have to say that, let's see what I would need to do. I need to say that, yeah, that 6 and 4 are supplementary and 5 and 3. And then I can say therefore 5 and 6 are the same. So I already know that 3 and 4 are the same, and I would use that congruent supplements. Go ahead.
oh, yeah.
You sure?
I have on step 2 right now.
So I'm going to say for my step 3 that just 6 and 4 and 5 and 3 are supplementary. So angle 6 and angle 4 are supplementary, and 5 and 3. And what would I say for, how do I know that to be true? How do I know that 6 and 4 are supplementary? You could say, I would take a couple of things. I would take linear pair. I would say angle addition had that third. Remember that? Angle addition has another piece that says if you have two together that make a straight line, they're supplementary. So anything along those lines will be fine. I'm going to say linear pair. And now I can say in line 4 that 5 and 6 are equal. And that's the congruent supplements theorem. Again, if you forget the name of it, so what, right? Write the phrase out for me, right? You could just write a small little paragraph that explains how you would know that. Or you could do a couple, you could do this in more steps if you just want to go piece by piece. You could say 6 plus 4 equals 180, 5 plus 3 equals 180. 3 and 4 are the same, so you can swap them out for each other. And then you could subtract them away, and you could end up with 5 being equal to 6 that way too, if you wanted. Hey, users, I got my 5 and 6. Hooray! So now that I have them, now that I have 5 and 6, can't I say these two triangles are congruent? We said angle side angle, right? Eve?
Do you have to have that RH?
Oh, yes, I didn't say that yet. Thank you. We marked it on a diagram, but never put it. Rookie mistake. RH congruent to itself. Reflexive. Awesome. Now I can say triangle. If I say RHC, what are you going to say? RHA. Oh my gosh, you guys are getting so good. ASA. And now I can say RC congruent to RA because of, you got it, CPCTC. Awesome. So I got the first part. Now all I need is the second part, but it's actually way easier because Is it way easier?
Well, if you get the.
Oh, yeah. Yeah, so why don't I, let's also tag on to that. Can I do CH is equal to HA for
Yeah.
CPC2C?
Yeah.
So let's add that on to our last step because that'll help me, because then all I'd have to say is this side that they share, and then I'll get the two bottom triangles. So I'm gonna tag right on to line 7, that CH is the same as HA. For the same reason. So for those bottom two triangles, all I need to say now is that HS is equal to itself. And then I get these two triangles, and then I can get the last two sides by CPC. Yes. All right, I'm gonna run out of room, that's okay. So HS is equal to itself. Reflexive. And I'll just continue over here because we're almost done. So now I can say triangle CHS. If I say CHS, you say, you got it, AHS, because of side angle side. Oh, side angle side, which means that CS is the same as AS because of, you got it, oh my gosh. I feel like you're little birdies and you have, your wings are full grown now. Look at you fly, CPCTC. So I think I'm finally ready to say whatever they wanted me to prove, that this thing is a kite. Brass is a kite. Yeah, because I did show that I had, so you can either write literally that you have two pairs of consecutive sides congruent, or you can just say definition of kite. Oops. Because we did it. So although it was a little bit of a longer one, it's not so bad, right? Especially if you know, all right, these are the things, I need to get one of these things. Ask yourself as you're going through it, well, what makes the most sense? Because some of them just, you know, it doesn't make sense to do the perpendicular diagonal one here. Is there a way? Probably. But I don't know. So thoughts? Is it so, especially if you have this in front of you, is that much better? The only way we're going to get better is by practicing, right? So we should do that, right? You got it. So let me give you some. Let's see, what did I print out for you? Okay, let me give you this, but I think oh yeah, okay, okay. Is the football game here or is it away?
Here.
Oh, it's here. Is everybody going? You are? That sounds fun. Welcome. What else do we have going on this weekend? Anything? What are we doing? Nothing? What are you doing, Carson? You are not afraid that it's gonna be so cold? Oh, it's covered. I didn't see it. That's not so bad, though. Of course you can. All right, hang on 1 second here.